This is quite a useful little trick to know for Maths Olympiads, and it's not that well known. So the claim is, given the integral that we know, the integral of sine to the power of n theta d theta for any even n, find the integral of cos to the n theta d theta in 1 second. And in actual fact, that claim is completely true. Now, the description, the links to the videos that I'm about to mention are in the description to this video, so anybody who so desires, go and watch them. But in the previous video, what we did was we discussed the integral of sine to the n theta d theta for any even n, and we came up with the formula 1 over 2 to the n minus 1 integral of cos n theta minus n1, which is Pascal's triangle, cos n minus 2 theta add n2 cos n minus 4 theta minus n3, sorry, not n over 3, n3, and this will mean something if you watch the previous video, n3 cos n minus 6 theta all the way to add n over 2 times a half d theta. So basically the integral of sine to the n theta d theta is the same as the integral of this entire expression here. And then what we did as an example, we did it for the integral of sine to the power of 8 theta d theta, which gives us 1 over 2 to the power of 7, just putting in n equals 8, the integral of cos 8 theta. And let's expand these. N1 is 8. It's the eighth line of the Pascal's triangle, so that's minus 8 cos of 6 theta. Add 8 times 7 over 2, which is 28 cos of 4 theta. Where are we? 28 cos of 4 theta. Minus 56, which is N3. That's 8 times 7 times 6 divided by 3 factorial, 56. Cos of 2 theta, add 8 4, which is 70 divided by 2, which is 35 d theta. This was for the example of sine to the power of 8 theta, and then when we integrated that, we got the answer to be 1 over 2 to the 7 sine of 8 theta over 8 minus 8 sine of 6 theta over 6. Add 28 sine of 4 theta over 4 minus 56 sine of 2 theta over 2, add 35 theta, add a constant of integration. So now we know what the integral of sine to the power of n theta d theta is, and so we also know what the integral of sine to the power of 8 theta d theta is, and so to the claim. Given that we know what the integral of sine to the n theta is, or as an example, given that we know the integral of sine to the 8 theta, how can we find the integral of cos to the n theta d theta in 1 second? Well, all you do is you replace the minuses with a plus. Voila. That is your answer. So you can do it in 1 second. It's not a claim which can't be substantiated. For those so interested, just to explain why that is the case, when we found the integral of sine to the n theta, d theta, we used z minus 1 over z equals 2i sine theta, and then we expanded that to the power of n, giving us 2 to the n I to the n sine to the n theta. If we were to do the same thing with cos to the n theta d theta, we would use z plus 1 over z to the power of, well, z plus 1 over z equals 2 cos theta, and then we would expand that to the power of n. So everything would be identical. I would cancel out because n is even, and we would end up with an identical expansion, except that every other element in the expansion would be minus here, and all of them would be plus here, but otherwise they would be absolutely identical. So that is why the integral of cos to the power of n theta d theta is almost identical to the integral of sine to the power of n d theta, except all of the negative terms are positive. And if you want to have a look at any of the videos that where we discussed all of this in detail, just look at the description to this video where there are the links.